Today we'll be looking at the volume of 3D shapes. Volume basically is the amount of space occupied that 3D shape, or think of it as you have to fill that entire object up with water. How much water would it take? Basically, we're going to look at some examples today using a formula sheet, again, the back side, but make sure you're using the right-hand column, the volume parts. We'll be looking at some simple shapes and some composite shapes. I'll jump right into the first example here. So we're looking at a pyramid. And the formula for the volume of a pyramid is V equals B squared H over 3. And I see a B, we're talking about base there, that's the size of one side of our square base pyramid, so in that case it would be 10. And because we're using H, that's our vertical height, the height from the point down to the center of the base, which in fact they've given us this time. No need to use Pythagoras to find any slant heights or any relationships there. So we have all the parts and pieces we need for this formula. Plug in the right things in the right spot. So B, 10 squared, times H divided by 3. You can put that all in your calculator at one time, and it'll come out to 400 centimeters. And this will be cubed this time because we have 3 dimensions. So all volumes are cubed. If you look at the second one, it looks to me like a composite shape. It's composed of 2 parts. I guess we need to find 2 volumes. Now, volume number 1 would be our cylinder. So V1 is pi r squared h. And volume number 2, the part at the top up there, kind of looks like a sphere, but it's half of 1, right? So a sphere has a more complicated formula, 4 pi r cubed over 3. And then afterwards, we need to divide that by 2. Okay? I'm going to do this in 2 separate parts. You could do in one big long equation if you want to, but I think it might be easier to work in parts. All right, the cylinder. So pi times our radius. Radius we have here at 1.25. We want to square that, and we want to times it by the height. The height of that cylinder is 4.5. And you can punch it all in our calculator the way it looks, and we end up with 22.09. If you go down to the sphere now, okay, 4 pi times the radius. Now the radius of the sphere, being here outwards, is the same as here, right? And that is the same as the radius of the cylinder because the sphere is sitting on top of the cylinder. So our radius is 1.25 cubed divided by 3. And then remember, it's half a sphere, so don't forget to divide by 2 at the end there. Okay. When we're finding the volume, the first part here, try and use that cube button on your calculator. It might be looks like the hat, or you might even have a power of 3 button, or an x to the y, or a y to the x. Try and use that button, the exponent button, to make your life a little bit easier. So 4 times pi times 1.25 cubed, all divided by 3. Punch that part in your calculator, you get 8.18. We'll divide that by 2 again, don't forget. And that comes up to 4.09. So then we want to find our total volume, the overall volume. We're going to take the 2 parts. Right? The part of the cylinder, 22.09, and the part of the half sphere, 4.09. And we get a total of 26.18. This is meters and cubed. And that takes us through a more complicated shape, in fact, a composite shape. Okay, look at the third example here. We have a box with a square base. Okay, square base is kind of important. So if I make a square on the bottom, and then a box, right, I've got a vertical height here, if you will. Okay, there's my box. The base is square, right? These 2 things are both going to be the same. The height is 12. So my height is 12. The volume of the box is 867. Find its length. Well, the length, I'll call it this piece, is the same as this piece, right? Because of the fact that it's a square. So if we look at the volume of a box, length times width times height, or because it's a square, length times height, both parts of the square base are the same. We can fill in the parts and pieces we know. We know the volume is 867. L times L, I don't know what those are, but I know that's L squared. So L squared. And H, I know, is 12. Well, L squared times 12 is the same as saying 12L squared. You usually write the numbers in front of the letters. And because I don't know L, but I do know the volume, I need to solve this. Sort of the things we did yesterday with similar, surface area. First thing we want to do is divide out the 12 from both sides. On the right-hand side, we'll be left with an L squared. On the left-hand side, we'll be left with 72.25, and that's what L squared is. So to find L, we can square root that, and if we do, we get 8.5 centimeters. Again, the key there is the fact that you recognize it's a square base. If it wasn't square base, we would not be able to solve this because we'd have two variables and we wouldn't be able to square root it or rearrange it or anything like that. And that takes us to the end of page 1.